Simon Willinson and Matt Biddulph. Thank you, James. This being a developer conference, I thought it would be a good idea to sort of close the day with something quite developer-focused. I wanted to talk about technology stacks, and in particular, I wanted to talk about how my experience building Lanyard has convinced me that the default stack for building an interesting web application has changed dramatically over the past sort of 4 or 5 years. You know, it used to be that it was LAMP, Linux, Apache, MySQL, PHP, and that was all you needed to build something. Today, there are a lot more moving parts involved if you want to build something interesting. And as I was putting together all of the things I wanted to talk about, I realized that each one of them was a conversation that I'd had with Matt Biddulph at some point over the last few years. Matt built Doppler using a lot of this stuff several years ago, and he's been an inspiration for a lot of the decisions we've made with Lanyard. And since he was here, I decided to invite him up on stage and turn this into more of a conversation about web technology stacks and startups in general. So I'm going to hand over to Matt, and we'll start talking about what we've been building with recently.
Okay, so as James says, there's so much we can learn from looking at what our active live startups do on the ground, and Lanyard is iterating incredibly on both their feature set and their technology stack. But Lanyard wasn't always a highly funded, professional, tech city startup. There's an origin story behind it. How did Lanyard come together, Simon, and how did the technology stack evolve with its unusual situation?
So Lanyard is it's a sort of classic example of a side project that grew into a startup. And the slightly unconventional origin story is that Natalie and I started Lanyard, and Natalie's there in the front row. We actually co-founded the company on our honeymoon. We got married back in June of 2010. We quit our jobs and went traveling around the world for as long as we could. And 3 months in, we sort of got stuck in Casablanca, feeling a bit too ill to move on, and had this idea for a project, and said, okay, well, we'll rent a flat for 2 weeks, we'll build the first version, we'll show it to some friends, and we'll see what happens. So the very first version of Lanyard was a JSON file that I'd meticulously plucked together of informational conferences, and a few lines of Python that pulled a Twitter name and told you if that person was following anyone who was speaking at a conference. And we sort of evolved it a tiny bit from that. We put something live for our friends. It was running on one server. It was a bit of Python and a MySQL database, and that was pretty much it. And they said, hey, yeah, that's quite useful, you should throw it open to people. Of course, the problem was that we built Lanyard against Twitter. The idea is that you sign in with Twitter, we look at who you're following, and we show you events that those people are attending or speaking at. And when you launch something that deals with Twitter, it turns out Twitter's sort of viral, and we hadn't really accounted for that. We launched the site, and 2 hours later, our single server with the database and the application things on the same thing was falling apart, and we had to scrounge around and pull up another Linode box and try and get things working. So it was one of those, I wouldn't say it was an overnight success, but it grew way, way faster than you'd ever expect a side project to grow. And a lot of the technology decisions we've made have been on the basis of you start with the simplest thing that could possibly work, and then you sort of scale it up as and when it starts hurting.
So there's so many components to the modern web stack that we can get for free from the community, from open source these days. But there's a huge amount of choice out there. You know, are you going to use Solr or Elasticsearch or something else for your search engine? What database are you going to use? What are sort of the biggest wins, the most sort of superpowers you've got from using open source software? What are your favorite pieces?
So I love that term, superpowers. I love this idea that if you pay attention to what's in your stack, to what components are out there, you can gain an enormous advantage over people who haven't figured this stuff out yet. So one of my absolute favorite examples is Redis, which has been mentioned already today. It turned up, a year and a half ago, maybe 2 years ago? And it was about 1,000 lines of C code that this guy in Sicily had written. And what Redis does is it exposes fundamental computer science data structures over a network interface. It's sort of a data structure server. So it's kind of like memcached in that you can store values in it and get them back out again. But it lets you work with higher level structures like sets or lists or queues. And it does it all in memory, and it does it incredibly fast. So once you've got something like Redis, certain operations that would have been really expensive with the database become so cheap they're practically free. My favorite example is we have a feature on Lanyard where you can go and look at a conference, and we'll show you all of the people who are attending that conference who you are also following on Twitter. And in Redis terms, that's a set intersection. We ask for the intersection of the set of people you follow and the set of people attending that conference, which Redis can do at a rate of 100,000 comparisons a second on my laptop. So on a proper server, it runs even faster. And this means that this feature, which if we'd built against the database would have had a significant performance impact, we'd have had to think about it, we didn't have to think about it at all. We could just roll it straight out.
So if it seems like these days there's so much choice out there, so many nice tools you could be incorporating into your stack, that we don't even have to feel like, okay, what's my choice of database? Am I going MySQL? Am I going Postgres? Why have just one database when you can have three in your architecture? And that's all well and good until you're recompiling drivers for Ruby or something else, the latest iteration of MongoDB. How do you introduce something like Redis into a system without just rewriting all your MySQL code to use Redis instead?
So the rule we've worked by, which has worked really well for us, is we use a relational database. We're actually using Amazon's RDS because when there's just one of you doing all of the sysadmin, it's nice to have Amazon deal with the MySQL config files for you. So we have a relational database, and all of our core data lives in that, and it's properly normalized, and it's a nicely designed schema. And then we denormalize things into other data stores. So the primary things we do are we denormalize some of our data into Redis, so anything where we might want to do a set intersection or pick a random item out of a list, we make sure that that's being updated into Redis as well. And we also denormalize our data into Solr, which is traditionally used as a full-text search engine, but it's actually got some really powerful facilities for doing other types of query, especially the kinds of query which databases might not deal with so well. So the benefit of doing that is that any normalization problems, any time you notice that there's a bug because the data here obviously isn't quite the same as the data over there, you've got your master in the database, and you can just repopulate the Solr index or the Redis index or whatever straight from it. So it makes it a lot easier to manage all of those different denormalizations.
So one of the advantages I think I had when we were first building Doppler, I had a lot of friends that I went to in the tech industry, and you want to go to people who've been there for a few years, sort of sit on their knee and hear the stories of what it was like in the olden days, and pitfalls that you should avoid.
You sat on Cal's knee.
I sat on Cal Henderson's knee. Just around the time he was writing the Scalable Websites book, and he told me some of his secrets, and not all of them were disgusting. But I learned from him, for example, some of the ways that Flickr shards their database. But one of the pitfalls definitely for a new startup or a new code base is, okay, I've read the book and I've seen how Flickr scales to millions and millions of users. I've read all the stuff about how Twitter is using this or that database. And then you rush with great glee into using some system that, while it will scale up if you do it right, doesn't necessarily scale down. That something that when you're using it on 1 or 2 or 10 machines rather than thousands, it has its hiccups at that level. So how do you go about spotting a technology that you think you can deploy in the early stages of a startup that will give you benefits later as well?
So the number one rule I've always had with evaluating technologies that I might want to use is I need to be able to download it and get it running and have it doing something useful within half an hour. And if it takes longer than half an hour, unless it's real pain points and I'm really going to need that thing, I tend to move on, especially when I'm sort of iterating again, when I'm working on startup stuff as opposed to just tinkering around. And I've found that filters out the good technologies pretty well. Things like Solr, Redis, MongoDB are all download, run a script, and start talking to it through a standard Python library or whatever. It does mean that there have been some things like Puppet, for example, which we didn't start using at Lanyard until quite a bit after we should have been using it, just because every time I sat down and tried to get Puppet working, half an hour would pass and I'd still be trying to figure out what was supposed to go on what machine. And actually, the solution for Puppet, it turned out, was to hire Tom Insom, who used to work with Matt at Doppler.
I've used that solution as well.
Yes, but nobody should hire Tom Insom. It's a terrible idea. But yeah, we did kind of save up a bunch of technical debt on the operations side of things, and sort of cross our fingers and hope that the site didn't crash until we could find ourselves a Tom Insom to make sure everything was running okay.
So there's a quote that I've completely lost the origin from. If anyone knows who originally said this, I'd love to hear it, because I've said it over and over again in different teams. I really believe that you shouldn't do R&D on a live project. That if you're deploying something, you should have at least some faith in it, and you shouldn't just be picking on the latest fashionable technology or trying something out because it looks good. you need a bit of experience because you're doing so much as a startup founder day to day, whether it's running your company or making product decisions or talking to investors and hopefully writing some code or building the product at some point. You just haven't got the time that you have normally to investigate every little piece that you're going to use. So I found it's over the 3 or so years of building Doppler, a lot of the systems I was incorporating, a lot of the choices for what I was going to deploy came from my experience of the previous years. So, for example, we never actually converted to using Git because although it was a fantastic system and I could see that it was going to be really powerful and useful, at that point, around when was this? I guess 2006 to 2009, I didn't personally feel confident in it. I hadn't had time to play with it properly. Can you tell me a bit about your experience, either during or running up to Lanyard, with bar camps, hack days? Tell us maybe a bit about the dev fort and how that informed your technology choices for Lanyard.
So Lanyard, we would not have been able to build Lanyard the way we did if I hadn't spent the 3 previous years having an awful lot of fun doing side projects, and I was working at The Guardian and doing some sort of experimental technology pieces there, as well as sort of more traditional work. And so I went into Lanyard with a whole sort of scope of technologies which I tried out on previous things and I knew were going to work. And some of those were still what you might consider relatively experimental. Things like Redis, I could use that at Lanyard because I previously used it for a project at The Guardian where it had worked out really well. That said, we've introduced new technologies into Lanyard, but we've been quite cautious with them. So we're now using MongoDB as an example, but because we'd never used it before, we've relegated it to logging for the moment. So for the first sort of few months of using Mongo, it was sat there accepting sort of error logs and other things like that. Stuff where if we lost it, it would be irritating, but it wouldn't be a complete fiasco. And now that Mongo's proved itself, we've started moving it into storing other bits of data as well. So Matt mentioned dev forts. This is a really fun thing that we did a few of in the past few years. There's this idea of hack days or hack weekends where a bunch of people get together and they hack something together in 48 hours. Some friends of ours decided it would be fun to extend that to a full week. And to make it interesting, they hired a fortress. They hired a Napoleonic sea fort on Alderney in the Channel Islands. And we took a dozen people out there and we spent a week hacking a project together. And that project turned into a side project, a site called wildlifenearyou.com. It was a great opportunity to experiment with a whole bunch of new technology ideas and things. But it's sort of the most creative environment you can imagine because you're on a fortress. There's no internet connection because you're on a fortress. So practically in the middle of the ocean. So you have to take everything with you. You bring all of the Debian repositories that you can find and every package off Ruby Gems and all of that kind of stuff. And you just get a solid week to try things out and build stuff with a bunch of people who are sort of equally excitable and technologically minded. And yeah, a lot of that sort of rapid prototyping, build something as fast as you can in a week, that was really useful in the first few months of building a startup.
Okay, so as we move towards the end of our time, you said in your introduction that there's a new web stack that even in the last 2, 3, or perhaps 5 years, it's no longer just about, okay, I get my database and I put a app server in front of it and a web server in front of that, the traditional sort of 3-tier web architecture. So what are all the things that you would deploy on day one of a new web stack, and how do they fit together?
So I think the crucial difference today is, firstly, it used to be that the biggest decision was which web framework were you going to use. Were you using PHP or Django or Rails or whatever? And that's still important, but much more important is the set of infrastructure that you build up around that. So one of the key examples is having some kind of message queue, or at the very least, some kind of offline worker process. With Lanyard, we're using a system called Celery, which is something that's very popular in the Python community. And it's a way of very simply firing off a piece of work onto a queue, which gets done by a background worker. And once that work is finished, it sticks the result in memcached so you can find it. And it's a bit of a fiddle to set up, but once you've got that, all sorts of things become super easy. Anything where you might be talking to an external API, which could take several seconds to return, or there's some kind of image processing job going on. You write a couple of lines of code, plug it into the message queue, and you've got that running in a way that's not going to hang your server if hundreds of people try it out all at once. So I think getting a message queue and a set of workers up and running on day one is absolutely critical. I'm a huge fan as well of having some kind of full-text search engine that's separate from the database running. I've used Solr very successfully closely in a bunch of projects. Elasticsearch is something we've experimented again with a sort of non-critical component, and it looks like it's getting to the point where it'd be a really good idea to deploy. But having that from day one and having the systems by which your database, the stuff in your database is being sensibly pushed into a search engine means that, again, all sorts of problems which would have been enormous problems suddenly become just, recycling a little bit of search code and knocking together something pretty quickly. And then the other one is Redis, which I think is in a category all of its own. It's not a cache, it's a data structure server. I suppose the only real alternative is if you're running on a Java stack and you just have a bunch of long-running processes with locks and semaphores and stuff on data structures. But with Redis, you don't need to have to think about any of that. It's got a very simple client API. Any of your systems can talk to it, and it's so screamingly fast that stuff which you would have had to think about as having potential performance impact just doesn't have any impact at all. But if you've got your application server, you've got your cache, you've got your message queue, you've got your full text indexer of some sort, maybe something like Varnish on the front end for speeding things up. I think that's a really good basis for a web stack which will let you innovate faster than people who haven't got all of those components in place. And really, for a startup, it turns out the technology isn't the challenge. The challenge is figuring out the right kind of features and quickly trying things out, seeing what sticks with users and what doesn't. And any technology advantage that you can find that means that you can iterate faster is something that's worth having.
So as James says, Simon is absolutely one of the most pragmatic and quick-footed developers that any of us know. So keep your eye on him, and if you see him make a technology choice, then that's certainly the next thing to be investigating. So join me in thanking Simon Willinson.
Oh. Thank you, Matt.